Time for NerdDraftPhysics.com video presentation. So we're back on the free momentum experiment. So I guess we'll say it's day 10 or something. you know, it's all junk and garbage. So no real explanation for how it's viable to have an idea like free momentum. So I guess we'll do that first. Well, we'll just point out that this Spar character has this video he's done, this weird little pendulum things, and they're very hard to tell what the hell these are, but they're cylindrical. That is, they're long objects with a string going through them that looks like it's about 4 inches long. So it's a very tight radius. He's using a wide angle lens. You can see that here. The ruler looks like a boomerang. Okay. And he's going to measure frame rates. And they suck. Simple truth. Just they suck. The frame rates suck. The images aren't even clear. They're turned flat on the edges. There's all kinds of defects. It's terrible video. And he's going to do a precise measurement. All right. And clearly he's too stupid to know you can't do it with this distortion in the first place, okay, the distorted ruler. And in the second place, both of these objects technically are rising. Because of his camera angle, you can't see that, but they're both rising as they move out away from each other. And it's how much they're lifted is deciding how much energy is being taken away from them or being given to them by gravity. And so essentially what you really want to do is measure the angle from the center of their mass to the apex and get the angle. So I guess I'll draw that kind of stuff. So anyway, he's done this stupid analysis video where he's taken his cruddy clips, the cruddy clips from the other video, and he's proud to announce that, well, my prediction is way off, from 50 to 100% off, and his prediction's only from 20 to 30% off. So he's proud of his measurements, knowing that he's not even getting close to his own prediction. He's got a 20% off, okay, average, and he's claiming that this is a really good experiment and it's going to prove the facts. And his own prediction is that far off. Yes, mine is proven to be more off, but frankly, what's off is obviously your analysis isn't consistent with. It's not within a range of error that's acceptable to say you've got the right theory. You're measuring the right stuff. So we'll go over that kind of crap. But it's the same old crap. Look, I'm done watching their videos. I'm sick of this. I've proven. We're back to the Ian Gosling hiding the video that didn't come out his way. No video. He doesn't show us the video that doesn't come out his way. I mean, it's all engineered crap, and that's all it is. They selectively choose what they're going to present and what they're going to analyze and what they're going to talk about. And again, they don't talk about anything close to a theory. So they have this theory that, yes, doesn't make any sense to me. I concede it's completely nonsensical. This theory that they can make free momentum, okay, that you can create an oscillator, okay, I can drop a 1 mass with a 100 momentum and hit a 3 mass with it, and I'll end up with 150 momentum, a huge increase in the momentum of the object moving away. And as pointed out, well, then why don't I just put a 9 mass next to the 3 mass, and I can increase it even more. And I can put a 27 mass and I can increase it even more. And I can just keep increasing it. Now obviously I could increase it in littler increments by just using say a 2 ounce, then a 4 ounce, and then an 8 ounce, and then a 16 ounce, and I could incrementally increase in that direction also. But the idea is anytime you hit a light thing into a heavy thing, you create free momentum in that direction. Now obviously this seems to have an infinity tied to it almost. That you can just keep making more and more momentum by just hanging heavier and heavier things and having something bang into a heavier thing. Which, it's got to give somebody, a reasonable person's got to say, boy, that is weird if that's actually true. And the idea is here, in this case, it's 150 this way and 50 this way, so it's actually made 100 atoms moving has now been converted into 200 atoms moving, is a way of looking at it. There's twice as much stuff moving of velocity. There's twice as much mv in the universe. And then it comes back together, 150 hits 50, okay, a car crash of 150, a truck, a car into a bicycle or a motorcycle, you could do a real world experiment, and they're basically saying, no, only 100 pops out. So 200 bits of momentum go into the crash, and only 100 momentums comes out. And they say we all should know that's exactly how the real world works. That with elastic objects, that is, objects that don't deform, there's no place for the momentum to disappear to. It can't escape anywhere. It has to escape in motion. And they're just basically saying, I destroy it. Because there really isn't. They can't say it was destroyed by a bunch of sounds or a bunch of vibrations or the earth shook or some other kind of crap, because it's not there. So they have to explain, where did it go? You had 200 momentums in a crash and only 100 pops out. There's something wrong with that picture. Because if I did it with cars, it's not going to work. Okay, indestructible cars. Alright, anyway. So he's got this wacky system with strings going through the things. There's a ton of things you could just say right off the bat. Where's the center of the mass? Okay, it's not marked, because that's what you're really trying to follow. And you're really just trying to follow one single point on the object. And obviously when it's moving this direction and this direction with a wide angle lens, you have all kinds of parallax problems. All kinds of, you're not seeing the right edge. The same thing you're looking at here, you can't see it when it's over here. When it's over here, that's behind you, over here. You can't see it even. You're seeing a different edge. You're not even seeing the right edge of the object. So you can't measure the physical shape of the object and say that's a frame. Now they're measuring single frames, which again, there's not much theory to defend using a single frame and saying you can get an accurate measurement from a single frame, especially right after an impact. Okay, not much chance of that. So big problems. So nowhere in his analysis does he even concede we really need to know this distance. What's the distance that the object is hanging down from? Because the real trick is knowing how far it goes, okay, its absolute, okay, amount of distance. That's easy to detect. You don't need frame rates to be specially perfect for that. And that'll tell you how fast something's going, how far it goes, how far up in gravity it went. Will tell you how much energy it had. So that's the one you're really after. But the only way you can do that is you have to know the distance. And you have to know whether both pendulums are, did he make both pendulums come off the same strings? I mean, the same location? Or are the two pendulums hanging from two different locations? I don't know how exactly to draw that perfectly. Are they hanging side by side, or are they hanging this way, where they're both off the same point? It's an important detail. Okay, no reason to know what he did exactly. Don't have this radius, okay, which is critical. And just this is like a 6-inch one right here, and you can see it's never flat. Okay, look at it. As much as we'd like it to be flat, it's not flat. The object doesn't move like a ruler. Okay, the object's moving up as it moves out. So its real distance is this curved line. It's traveling a curved line. It's not traveling a straight line. So if you want to get the real distance it traveled, if you want to get real distance, you need to get the curved line distance, not the flat line distance. So that's an error right there. And again, the idea is really to know how high it started from. And you don't do that by measuring from here to here. You don't measure from some ground and measure up. No, you measure from here down. And you measure from here down. What's this height change versus this height change? So when it's arcing, going through this cycle, the idea is to find out how high it went. And how high it went will tell you how much velocity it had to do to reach that height. And so obviously, as you drop something, it gains a lot of down force, okay, through this travel, and it's doing mostly sideways motion in here. So the velocities will be more stable here, but they're still changing. You can see it's still a rather real arc here. There's a real arc here. Okay, so even a little bit of distance is still a substantial amount of up and down. So there's still a large component of up and down. And that's the real catch. A little bit of up here is a lot more resistance to motion, okay, to overcome. You need a lot more energy to do 1 inch here than you need to do here. 1 inch of movement here is almost unresisted. 1 inch of motion here is resisted by a full, 9.8, a lot of resistance. He didn't take any of this stuff into account at all. He's just doing some basic flat linear measurement on a wide angle lens that's distorting. That is, the stuff over here is bigger than the stuff here in the middle. And then claiming that those measurements of single frames in a video are reliable enough to draw a conclusion about how much energy or velocity the objects had. And as I stated when I first showed the first video with he did a 1:4 ratio. When I showed the 1:3 video, I pointed out the frame rates just aren't good enough. We need a better experiment. And then once we have the better experiment, let's put the heavier object next to the 3. Let's put a twice as heavy thing next to it, and then it should be 133. We can gain 133 by just putting a twice as heavy next to it. And just keep going and doing that over and over again and see how much free momentum we can actually build up. And then how much you can destroy. Because that's what they're claiming. All of the energy I can create, I can destroy it. So I can finally get this going 338, and I can have it swing back into something going 125, and somehow only 100 will pop back out. Magically. All the momentum will somehow be destroyed. So it's a junk experiment. It needs to be done much better, and the analysis is much more complicated. I mean, the ideal probably would be to be able to take a good image of the strings holding it. But again, if there's, he has it strung in such a fashion that he has them strung really wide. So they're on a very short radius. And so to get a view of the strings from the side, they don't line up. The two strings aren't going to line up. So the back string is going to give you a different angle than the front string is going to give you. But I mean, ideally, that's what would be nice to be able to do, is just compare the angles. So if you can get the angle, then you can figure out how much velocity it had to have, how much distance up it did to create that angle. But again, when he's doing his experiment, these holes are gigantic, and the string actually can move inside that hole. So when the weight's moving, it rolls on the string, changing the center of mass's location relative to the string. So even that he didn't stabilize. And yes, you probably should put a little red dot right where the center of the mass is, or at least the center of the string, so at least you have one fixed spot to measure, rather than a surface that's constantly changing. So lots of defects, large defects, and he's claiming again a proof. This is all you need to believe in this miraculous create free momentum, destroy free momentum theory. As if momentum doesn't mean something significant. As if momentum, as Newton said, Newton thought of momentum as being an equal to force. That's an absolute truth. So, you have to kind of accept then that you're saying something that's pretty challenges in Newton's understanding for sure. And you're making a statement about somehow you can make more force. making more momentum is making more force. And I don't think you can do that, really. And I don't think these experiments are nearly good enough for you to claim you've proven you have done it. And the implications, as stated, I think can be proven that it ain't going to work. Because if you can make that free momentum, I can find a device that will take the momentum of this 3 object, and it will launch a 1 object with that same momentum, and then I'll have a free energy machine. So I don't think it works. I don't think hydraulics proves it can't work, frankly, because a hydraulic system is not going to let you do these tricks. If I put real momentum, this 150 momentum, into a hydraulic system, it's not going to produce 100 momentums out. Ain't going to happen. Alright, so that's enough. I mean, it's a junk video. It's way oversold, again, as they're all oversold. Just like Brozo, he did an experiment where he got the answer of 14. His prediction was 16. My prediction was 12, and he claimed victory. Now, in this case, they're saying my prediction is, much further off than his prediction. But clearly he's only saying that because he's doing a silly linear measurement to something you can't measure with a linear ruler, because it's not a straight line, okay? And look, it's kind of obvious, okay? His experiment, again, his experiment has less of an arc here, okay? This circle that his is on is even shorter than this one. It's a lot less than this 6 inches or so. And so you can understand that this arc, you don't have to go very far before you're already lifting quite a bit. And there's no evidence of that in this video. You can't see any of that because of the way it's filmed. So right there, it's a deception. Alright. But these people are just so frickin' out of control in terms of their rhetoric, their exaggerations, and again, their inability to provide any kind of reasoning where how exactly is it consistent with the world we live in that you can create something called free momentum. That I can actually do that. I can have a machine make free momentum. I can put 100 pushes of momentum in, 100 pounds of weight, and I can get 150 pounds out. It's just not in this universe. Alright. So it's almost like they're saying that yes, you could do this on a thruster on a spaceship and somehow just make automatically more thrust. Right, just by forcing the mechanism that you're going to use to create thrust to just hit a heavier object first and bounce it against a wall, and you'll instantly make more momentum than you started with. And now you can let go of that momentum into the space and actually move your spaceship more. Free momentum is a real problem. It's not just, oh, no big deal. Destroying momentum is a big deal. And they're just pretending it's not. And yes, it is. It's a bold accusation that the world works that way, and their evidence doesn't fit. It's not that it's an extraordinary claim, but it's certainly beyond ordinary. And their evidence should be a little higher, a lot higher, frankly, than crappy. I mean, they should have at least ordinarily precise evidence, and they have unordinarily imprecise. Yeah, enough said. But yeah, until they do something credible, I'm not going to waste much time on them.